Today in class, we will be talking about motion equations as objects projected up. As you know, our three motion equations are v equal v naught plus acceleration times time. Delta x equals 1/2 v naught plus v times time. And also, delta x equals v naught plus 1/2 at squared. All objects on the earth all experience the same acceleration, called gravity. Gravity is equal to 9.8, but we will use 10 in this class. It is written as g. Its vector could be negative or positive depending on whether or not you say that the ground is positive or up is positive. And acceleration will always be constant because gravity is a never-changing force, and it will always be 10 in our class, or 9.8 in other places. For example, a football is thrown up with an initial speed of 10 meters per second. How high does the football get? First off, I fill out my chart and find out what I don't know. So I know v naught equals 10 meters per second, v equals 0, delta x, I don't know, and acceleration is negative 10 meters per second. The time, I don't know. So I'm trying to find out the delta x. So I use the equation v equals v naught plus 18. I need to find t in order to find v. So I plug in everything that I know into the equation, and I find out that t equals 1. Then I go on to plug in t into the equation delta x equals 1/2 v naught plus v times t. And then I plug in all my points, and I get that delta x equals 5 meters. So the football gets up to 5 meters tall. Alright. B. How long does it take to reach the ground? Since I know that v naught's 10, I know that v will equal negative 10 because no matter how high off the ground the ball is, it would have the same velocity but just in different negative or positive forms. Because it doesn't matter where the ball is placed on it, above or below the ground. And I know that delta x would be 0 because it has reached the ground, and then our acceleration rate is 10, gravity, and I'm looking for t. So I will use the equation delta x equals v naught plus 1/2 at squared, and when I do all that, my time equals 3.8 seconds.